Transistor. In earlier videos we discussed about that the p type of materials and n type of materials, and as well as the p-n junction diode and the applications of p-n junction diode whenever it is connected in forward bias and connected in reverse bias. Then LED, solar cell, photodiode, about that we have discussed. Now we are going to discuss about when a p-type of a crystal means the positive holes consist by the p-type of a semiconductor material. In that p-type of a crystal is sandwiched with the n-type of a two crystals, or n-type of a crystal is sandwiched with two p-type of a crystals, then a transistor is formed. Transistor, which is a device which can be done with here the oscillation, is the amplification and rectification, as well as it can do much more. So in that case, first of all, what is transistor? Transistor means it's a combination of two words, that is transfer and resistor. Means here we can take that a transistor consists of a p-type of a crystal is sandwiched with between the two n-type of crystals, or n-type of a crystal is sandwiched between the two p-type of a crystals, then the transistors, two type of a transistors can be formed. Those are here the transistors are two types, that is PNP and NPN. PNP and NPN are the two type of a transistors. Here the PNP means this is the positive is considered as a emitter, and in this case of this one is base and this one is a collector. And in case of NPN is also there, this is considered as emitter and this one is base and this one is a collector. This is the NPN transistor. Means here the n-type of a crystal, n-type crystal is sandwiched with the two p-type of crystals, then the PNP transistor can be formed. And as well as here the p-type of a crystal is sandwiched with two n-type of a crystals, then the NPN transistor can be formed. N transistor can do amplification, oscillation and as well as rectification also. So that's why we can say that the transistor much more can do in the electronic device wide rangely using the transistors. So here it is that the symbols of the two transistors, so that is PNP transistor and NPN transistor, symbols of both. These are the PNP transistor. Listen carefully, this is the most important for the intermediate public examination for the 2 marks. He asked for the draw the symbols of PNP and NPN transistors. Then these are all this. Here this is the symbol of a PNP transistor and as well as this one is the NPN transistor. In this case of the arrow will gives the difference between the PNP and NPN, because of we know that always charge flows from the positive to the negative, right? So from plus to the minus. Here the P consists of, we know that P consists of holes, majority charge carriers are holes, and N consists of majority charge carriers are electrons. Means always current flows from the positive terminal to the negative terminal. Here is also always the holes moves from the P to N. So that's why here PNP means this is the P terminal and this is the N terminal and this one is the P terminal. Here is that whenever the current flows from emitter to always emitter to means this p type to the n type. So that's why arrow is directed towards the emitter to base, that p side to the n side terminal. Then this will be the PNP transistor symbol of PNP transistor. Here is the direction will shows the flow of charges. Either in case of NPN transistor, here we know that this is N terminal, this is P terminal and this is N terminal. Then current flows from the P side to the N side. Here we can say that from P to N, the majority charge carriers in N is electron. So that's why these holes occupies the electrons always. So here is also holes occupies the electrons. So that's why here from P side to the N side, the arrow will gives the from base to the emitter, then the arrow will gives the difference between the NPN PNP transistor, that is the direction of flow of majority charge carriers, which is consist of it is a heavily doped materials is consist of the will decide the direction of charge. So that's why here the heavily doped emitter is having that P type of a semiconductor, and so that's why here from the holes to the electrons. Here is also emitter is having the N type of it is connected majority charge carriers in and the other electrons. So that's why the flow from the P to N, always P to N be the direction. So that's why here PNP and NPN. The arrow must be denoted between the emitter to the base. Why? Because of here, let's see, the transistor can does a rectification, amplification, oscillation also. We know that, we already discussed about that. And also transistor is a combination of two words, that is a resistor and a transfer and a resistor. So that's why the transfer from emitter, these are the three parts consist of, transistor consists of three parts. Those are emitter, base, collector. Emitter, base, collector as the three parts consist by the transistor. Here is that, first of all, the emitter. What is meant by the emitter? This one is the consider it's a NPN transistor. This is a emitter. The terminal is a emitter. In this case, it's a heavily doped crystal which supplies the majority charge carriers. Means in this case of, this is a majority, this is highly doped crystal, either N type of a crystal or P type of a crystal, whatever it is. In case of the emitter is a, whatever the emitter, this is emitter, this is base, this is collector. So here it is that the emitter is a heavily doped, this is heavily doped. So that's why this gives the majority charge carriers. Means the main role played by the majority charge carriers to the conduction, So that's why emitter is a emits the majority charge carriers, means it gives the majority charge carriers to the circuit whenever it is connected in the circuit, and is also, it's a thinner than the collector. It is thinner than the collector and thicker than the base, means it is having the middle in a size. So that's why here almost all for the commercial for our convenience, to show the commercially, to show our for our convenience, the collector emitter can be drawn with the same size. So but it is thinner than collector, the emitter is thinner than collector and thicker than base. So here it is that is emitter is a heavily doped crystal which supplies the majority charge carriers either in PNP or NPN transistors. Emitter is a heavily doped crystal which supplies the majority charge carriers, and it is thinner than collector and thicker than base. Thinner than collector and thicker than base. In the circuits, the charges supplied by the emitter only. The next one, base. It is a lightly doped crystal. Base is a lightly doped crystal which is always, it's a very thin material, thin size. It passes the most of the emitter injected charges. Means whenever the charges are injected to the, from the emitter to the base, the total emitted charge carriers from the emitter can be passed to the collector. Most of the charges, whatever the most of the majority charge carriers passes towards the collector. Means when the emitter emits the majority charge carriers and send it to the base, then that base will passes the total majority carriers into the collector. Total majority charge carriers sent to the collector. Most of the charge carriers are sent by the base to the collector. That is the function of a base. That is only base will transfer the emitter, means which emits the majority charge carriers in the circuit. It is sent to the towards the junction. This is the junction and is sent to the base, and base which passes the majority charge carriers which is emitted by the emitter into the collector. Means transfer, that will transfer the collector. That is the main role of a base. And one more thing is, last one is a collector. It is a normally means moderately doped crystal, thicker than a, this is the most thicker one, because of most of this time more than the thick, this is the thicker one. So it is the function to remove the charges, at the junction, means whatever the charges lied at the junction, means collector base junction is there. Here the junction between the base and the collector, means whenever this emitter, base, collector at the junction, we remove the charges from its junction with the base, means it will transfer the electrons and it will emit the electron, it will emit the charges, and as well as the base will transfer the charges, and this collector will remove the charges. So that's why whenever it is removes the collector due to the magnetic charge carriers pass at the junction, it will combine with the charge carriers, and means electron hole pair can be formed, so that the collector current will be done. So that's why here the collector current most of the here will considered as a emitter current, due to the charge carriers are supplied, majority charge carriers supplied by the emitter. So that's why here the collector current will pass us through the circuit. So here it is the about the primary information about the transistor. First of all, transistor means it's a sandwichly biased one type of a crystal with the another two type of crystals sandwichly, then that is called as transistor. Means either then a p type of a crystal is sandwiched between the n type of a crystals, or n type of a crystal is sandwiched between the p type of a crystals is considered as a transistor. Either PNP or NPN transistor. There is a two type of transistors are there. In this case of PNP and NPN transistor. In this case, the first one is considered as a emitter, which is heavily doped, but it is thinner than collector and thicker than base, which is medium. So in the case of that second one is these are the symbols of transistors, that is PNP and NPN. The arrow will gives the direction will gives the difference between the PNP and NPN. Always flows from the charges flows from the P to N. So that's why here PNP. So that's why P to N. Only the arrow should put between the emitter and base only, because of emitter emits the majority charge carriers and base will take that values and take the charges and transfer it into the collector. So that's why here emitter always positive to negative. Emitter means here P type from always direction shows from P side to N side. Here is also P side to N side, because of we know that emitter will emit if the direction is in this case of electrons will always attract the holes. So that's why here the N means the majority charge carriers are electrons. So that's why from the positive side to the negative side always charge will flow. So that's why here taken that is in along the P to N direction, the direction will be shown. This is the NPN PNP diode PNP transistor symbols. In this case of the transistor consists of three parts, that is they are the emitter, base, collector. In the case of emitter is a heavily doped crystal. It is the first one is this a heavily doped crystal, and which is considered a emitter and which emits the majority charge carriers, which is injected or supplies the majority charge carriers into the circuit. Then it is thinner than a collector and thicker than a base. So, but in case of for our convenience, we will write that collector and emitter in the same size. The base will be in a small size. So next one is a base. It is a lightly doped, which is passes the charges which is emitted from the emitter. So that's why he passes to the collector. And the collector it is the moderately doped crystal and thickest one in the transistor, and as well as its function to remove the charges at the base collector junction. And this is the base collector junction. It removes the base collector junction. It removes the charges in the base collector junction. This is about the primary information about the transistors.